You're telling ChatGPT, hey, how would I find the largest file on my hard drive? It could give you the command, but it cannot run the command on your hard drive. By tool use, we're able to just bypass all of that and let the model have sort of like a side channel where it is saying, okay, these are tokens that I'm not emitting for the user to read. Stop for a second. You should run a certain function or a certain tool. The tools combined with the context and the model and the agentic harness around all of that is the thing that makes an agent, as opposed to sort of like just the model, which is like a brain in a jar. It cannot do anything.
The 41K versus the 1.1K between Claude and Codex, that's super significant. Talk us through kind of like, I guess, the split in the tools.
Our sense is that Sonnet 4.5, Opus 4.5 do better than the Codex models in using other tools. There is reason to believe that the model would be capable with new tools that it's never seen because it's like more of a generalist as opposed to has been trained on those tools in particular.
Before we jump into this episode, I wanted to let you know that this podcast is for developers building with AI at the core. So whether that's exploring the latest tools, the workflows, or the best practices, this podcast's for you. A really quick ask, 90% of people who are listening to this haven't yet subscribed. So if this content has helped you build smarter, hit that subscribe button and maybe a like. All right, back to the episode.
Hello and welcome to another episode of the AI Native Dev. And my name's Simon Maple. I'm your host for today. And joining me is Yaniv Aknin.
Hi.
And Yaniv is a software engineer from Tessl. Yaniv, you've done a huge amount of research on some super interesting things about, understanding how context can be used to better enable some of the top tier agents in our industry today. You're a software engineer. You've done a little bit in the AI engineering space. Tell us a little bit about yourself.
Yeah, thanks, Simon. So I've been with Tessl since the start. I think we joined at the same time, give or take. I've done a bunch of roles and basically change role and shift shape to fit whatever is necessary. I've led and kind of like started the AI engineering team, but now have focused more on working with customers. But still, in working with customers, some just understanding what could best serve a customer, or how would whatever context is relevant to a customer would fit in with an agent, requires us to actually, oftentimes we look at what customers are doing, but sometimes actually look at what the agents are doing and seeing how the two things fit. So what context do the agents come with built in? Like when you download Claude Code, Codex, Gemini, and so on, what is actually told to it internally, and then you see how do you fit whatever else you're feeding to it externally to see the two things kind of like gel well together.
Yeah.
So that's been the underlying thought behind the research, right? Like, let's see what is in those agents, what is being told to them. So let's talk about that.
And you gave this as a lunch and learn here in the office. In fact, there's a lunch and learn happening right now from Maria, who actually was on the podcast. Last week, in fact. It was released last week. And she's giving another wonderful session today. You gave this session a week ago as a lunch and learn.
At lunch and learn.
And we thought, wow, we were blown away by the information first off. And then we were like, we definitely have to get this on the podcast. We need to share this. But this information is for Tessl's really own knowledge initially. It wasn't something that we were originally going to share. It was for our learnings, right?
It's so we started looking into this. I can't remember when did we start. As soon as Tessl started, basically, as soon as agents appeared, we definitely started looking at how do they work. Kind of like packaging it up a bit and preparing for presentation was for a meetup that was happening here in London. And then we said, okay, maybe we'll do like an extended director's cut for lunch and learn. And then afterwards we said, hey, maybe there's content for a podcast here. So let's do that.
Cool.
So here we are.
So we're gonna kick off with, I guess, a little bit about some baseline statistics for agents. Some of the top tier agents that I guess most people of our listeners would probably maybe use today. Then we're going to look at what kind of things will actually change that performance, better enable agents to perform their tasks more effectively. Everything from looking at system prompts to the information that's given in a prompt, then looking at things like the tool usage, what tools are available to agents, and how that affects their capability, and more. So, where do we start, Yaniv? Should we have a look at the baseline for how agents work today?
If I can, like one thing we should remember before we do, we'll talk exactly about the baseline or like the the agent with nothing in it, basically, to start with, right? Like, yeah. But before we do that, just a quick reminder to everyone. We're doing this to best understand what context to give agents. We cannot speak on behalf, while we're talking about like flagship agents that you may have heard of. We can't speak on behalf of those companies. We don't have any internal material from them. We're trying to understand how to best use the product we're being given. And so some of the things we say, I hope they're right. They might also be wrong. If you have a different perspective, if your understanding of how, say, Claude Code or Gemini works, please let us know. And we're showing you the research as it's happening, basically.
Yeah, absolutely.
So,
sounds good. Let's jump in.
With this, let's go to the minimalistic agent.
Absolutely.
Right? Okay. So on the screen, what we can see here is the code for something I called the nano agent for the meetup. I basically vibe coded in like an hour. There's nothing particularly interesting here, other than the fact that there is nothing particularly interesting. Like, the interesting thing is that this is a working coding agent that I wouldn't say would win you any awards, but is actually quite capable. So
this is Python, right?
This is in Python.
I wouldn't say it's quite capable. Then it's
it's not as capable if we wrote it in 100 lines of Java.
There we go.
Exactly.
At least 100 lines of Java.
At least 100 lines of Java.
Yeah.
And then some libraries and some XML. Exactly to get started.
Yeah.
Okay. But in Python, this is what I wrote. And frankly, I think I could have done without the write file and read file tools. I think just execute and the run agent loop would have been enough. But if we look at the bits here, we have the system prompt, which you can read as like 250 bytes. And it just says, hey, you're a coding agent, do well. And the execute commands allow the model to run any command on whatever is the environment this is running on. I'm running it in a container. And then write file and read file, because I felt that will be easier for a human to understand, that if we would have seen the model doing an execute command and trying to echo something into something or cat something to read a file. So just to have explicit tools for read and write would probably be okay, even with just execute. But maybe the heart of the agent is the run agent function, where we see we're initializing the model, we're giving it the tools, right? Like the other functions are given to it as tools. I'm using here a library called LLM by Simon Willison, great library in my opinion. And then we're creating a conversation where we're starting with the system prompt and whatever the user has told the agent to do, sort of like the goal. And now the agent runs in a loop saying, okay, what can I do to achieve this goal? And we're counting on the model, the underlying model that we're using to power this thing. I ran it with Sonnet 4.5, but whatever recent model you'd use, to say, oh, well, given this goal and given this prompt and given that I have this tool, I need to understand what's going on here. I need to start reading what files already exist in the file system. I need to run ls. I need to run a read. I need to understand what's going on, and then start actually getting towards the goal. If I tell it, make me a to-do app, I need to start writing files. I need to execute a test. I need to check that things are working, until eventually this while tool calls and the number of available turns is done. So the model saying, I don't want to call any more tools, or we've ran out of turns, and then we have something complete. So that's it. In 100 lines, you get an agent, and you're thinking, well, it's probably not a very capable agent, is it? And I can't say it's very capable. I mean, I'm sure it's not very capable. But if you ask it to, hey, make me a to-do app, don't overcomplicate it. This is for a demo. Just, put something nice on the screen and make it look good and so on. You get a working to-do app from this like under 100 line agent. It looks great. It works. Like, you click around, you can manage your to-dos. I don't know. You can vibe code with this. I wouldn't say as well as you would with the flagship agents, but absolutely works and provides good results. And this isn't a new observation that I've made, or I don't know, Tessl have made. Like I said, I wouldn't say it's a very capable agent, but if you actually look at the scores for Terminal Bench, a popular and I think quite a respectable benchmark.
We use it. We use it
also internally, exactly for evals that we run. You see there only 15th place. So, okay, not first place and not second place, but not 100th place. Only 15th place is Mini SWE Agent from the same lab that made SWE Bench and SWE Agent and so on. And you see that they have Mini SWE Agent, which is also under 100 lines. They do 100 lines for the core agentic loop, and then I think they give themselves another 100 lines for, I don't remember if it's tool use or something else, but still, you can read the code in one sitting very, very comfortably. And yet it gets to a very respectable 15th place. And also if you see kind of like the distribution of scores, it's not like 15th place and really, really far below 14th place or 13th place. It's actually in a pretty good cohort. And I would say maybe on par, maybe a bit below actual like serious agents.
So what is this telling us is the kind of like the thing which makes agents, that much better?
Based on this alone, I would say, well, looks like maybe tools and context are not that important, because even with very little tools and with very little context, look, in 100 lines, you don't have much to work with. You can get to a good score. So you might think that. It could also suspect that there are things that terminal bench doesn't cover. Right. And at the end of the day, benchmarking is an art and an extremely difficult and like challenging task to do like really well. Perhaps there are real world situations where the flagship agents, the big brothers of mini-SWE agent would do better because they have this additional context, additional tools, and so on. So is it that context doesn't really matter? If it doesn't really matter, how come the flagship agents all come with loads of context? And actually, what kind of context do they come in with?
And the context you're talking about here,
question we're asking.
And the context you're talking about here is specifically the system context, right?
Correct. I should be clear about that, because when we say context, we usually mean the context that you add to the agent, right? So we don't usually think about the context that comes built in the agent. And that is primarily the system context and tool descriptions. So if you're thinking about the call that's being made to the LLM, there's a certain amount of input tokens. At the end of them is somewhere as though it doesn't have to be at the end. Typically at the end would be the user's request, make me a to-do app. But first, there's a lot of your Claude code or your Gemini or your Codex. You're a helpful agent. This is what you do. This is how you behave. Here are all the tools available to you. And for each tool, this is the schema of the tool. This is the description of the tool. This is when you should be using the tool. So this is exactly kind of like what we'd like to be looking into. What do the big labs choose to equip their agents with? Kind of like the built-in context, not the context that is being added to it. So what do they choose to put built in? What descriptions and what tools do they choose to make available? And how does that affect agent performance? And how does that affect
and of course,
the context will give?
To add some context, if you don't mind the pun. I'm sure you enjoyed that.
I do mind the pun, but well, you've been working together for a while.
Once it's out, I can't take it.
Exactly.
To add some overall context to the research, what you're interested in, or what Tessl is interested in, is of course adding our own context, or adding context that allows the agent to perform a certain task then better. And it's additional agent which is very core to that task, so that the agent has a better chance of actually being able to complete that task. Whereas the system context is kind of like more of a generic context that just makes that agent be able to perform general tasks, and even general in terms of coding and things like that. So what we're going to see here is more going to be next focused on system prompt and the system context. So I'd love to kind of like, learn some of your findings in that system context.
100%. The reason we're looking into it is that at the end of the day, when you're invoking the model, all of that context gets mixed together, and the model, it gets mixed together in some order with some words that would describe, here is the section that you should be reading in this sense or whatever, but still it all gets mixed together and gets shipped to the model. So you need to understand the built-in context. I don't know that there's a term of art for this, but the system prompt and the tool descriptions in order to add your own context. At the end of the day, the whole thing gets shipped to including the user prompt and including everything, and the model needs to start creating output tokens. So we'd better understand these things to learn from the big labs. Probably they know what they're doing in terms of creating tools, but also to be compatible with the big labs and ensure that the context that we're providing doesn't contradict and sits well with the context that we know is there.
So we can
so we can be more effective in our external context.
What I love to call mechanical sympathy. It's understanding what is under the covers. Like I don't need to understand. I don't need to understand a gearbox, how it works perfectly. In order to use it, because my use of it is literally using the gear stick. But as a Formula One driver, them understanding how it works under the covers will actually allow them to get every benefit of that.
100%.
And so this is essentially
100%, right? Like know where are the studs when you want to hang a picture, right? Like you need to understand what's behind the wall. Exactly. So if you want to look, I want to look at context. I want to read the system prompt. You can, but it depends how you do it, how would you extract and so on. But you can, because it's English, right? If you've read a book, you can read the system prompt, right? But also it's pretty difficult to show it in a podcast because it's not that interesting. Right? It's like showing someone reading a book, or I could show you the pages of the book to the camera. It's interesting to talk about size first. Like, yes, that's something we can talk about in a podcast. We're talking about around 12 kilobytes of context that we've seen in Claude.
Yep.
Around 10 kilobytes of context, I mean specifically system prompt, 10 or 10.7 kilobytes that we've seen in Codex, and around 14.7 kilobytes that we've seen in Gemini. And obviously they're adjusting this a bit as the versions of these agents change. I don't know if that's exactly what you'll be seeing for your version, but that's roughly the amounts we're talking about, 12, 10, 14.
And Claude and Gemini here, we're talking about Claude Code and Gemini CLI?
Correct. Okay. Yeah, it should be clarified, exactly. But now, okay, so 12 kilobytes, 10 kilobytes, 14 kilobytes, about 12 pages of text. What goes into those pages of text? I felt that this visualization, right, like the tree map with colors, is a useful way to give you a sense of what is in the system prompt without sitting down with a book and reading it. So to me, this is like creating a sort of like an index or a legend for the book, and giving you a chance to see out of the system prompt how many words were spent talking about the process or how the agent should work, versus about safety, versus about how to communicate with the user, how to write tests, and so on and so forth, right? Like you can see the tree map on the screen.
The difference is quite, you would have thought they would have similar learnings, as a result have kind of like similar splits, particularly with some of the biggest ones that they've got.
Yes.
But looking here, I mean, you look at the two biggest sections on Claude, it's different to the two biggest sections on Codex. And then with Gemini, actually, it uses one of each of the biggest two. It's surprising how different they are.
The difference was surprising to me. That's true. And especially it's surprising given that in the back of my mind, I keep remembering sort of like the null hypothesis, or the zero agent, right? It also works without any of this stuff. So what makes them put in 10 kilobytes, 12 kilobytes, 14 kilobytes, when I'm knowing that it works pretty well? Like, I imagine there needs to be quite a lot of value in the system prompt for them to bother to put it in. So I don't know exactly why are the differences as they are. I think you can look at the chart yourself and sort of like have a sense for what you're seeing. You can go and read the text yourself and have a sense for what you're seeing. But to me, like, reading it as an outsider, it felt like there are certain properties or traits that the model came out with out of training and after reinforcement learning and post-training and everything, and were things that the lab wanted to emphasize or wanted to subdue a bit, right? So all prompts talk about be direct, be clear, do not waste tokens, like follow the instruction of the user, that kind of thing. But now I'm making a hypothesis. I don't know. Maybe there's more about use of tests in Claude than in the other agents, because they felt that after the model came out of training, it needs a bit more leg up on tests. Or there's more about the process and how to manage your work, right? Like when I say process, I mean making to-dos, or how to decide, how to plan ahead. Because after training for Gemini and Claude, they felt they wanted to assist the model more. So that's my hypothesis. I don't know if that's a very good way to think about it, but a bit like a patch in software, right? Like you're patching the bits where the model didn't do exactly as you wanted, so you're giving it a leg up using the context, using the system prompt.
And of course, we can't like directly compare each of these to say, oh, Claude's doing it this way, Codex is doing it that way, because of course they're different models as well. So the different models are going to act differently and potentially require different support in different areas, or different direction rules in different areas, to be able for both of those models to actually achieve the same thing. So that's obviously specific to each model as well, but incredibly curious. Which were you most surprised at, would you say?
I think for me, the way that Claude manages process and manages planning was quite distinct from Codex and Gemini, and doesn't necessarily even is not so visible in the chart. Codex, you can see there's very little on process. Gemini, there's more, but it's differently framed and like used differently. We'll see that again a bit further on when we talk about tool use and the tools that are available to each of these agents, and how does Claude use the to-do tool very differently to the other two. But also, Claude leans very heavily on the idea of subagents and on delegating tasks to sort of like a separate agentic loop with its own context and its own use of tokens. So saying, okay, you go and do this task for me. Afterwards, I don't care what context you've built while doing the task. I just care about the result, and I'll continue from there. And Claude is using that in the most flexible manner, I would say.
And that's captured in the process, presumably, or is it more in the tools process? Okay,
interesting. Would be useful to say a word about how do they come up with these tree maps. Basically, taking the text of the system prompt and then sort of like asking a model to come up with a classification for every line in the text. So if we switch to another slide, for example, it looks like a bar chart, but it's not really a bar chart. I've used a bar chart to represent the text. So imagine that every pixel is a word or a letter. I don't remember which I've used. And the labels that I've added are the things that are determining the color of the line. So it's a bit like the minimap in your editor, right? Like many VS Code and other editors often have like this minimap of the code on the side with syntax highlighting. So this is not syntax highlighting. This is context classification category highlighting. So for every line, we're adding, oh, this is about coding philosophy. This is about an approach to testing. This is about safety. This is about process and whatever. And then we're coloring the lines appropriately. You get a sense for volume and for line length. You can see how many lines there are and how long they are. Not hugely different, but somewhat different. And you get a sense for what are the lines about, right? Like the label that we see through the color. And we see these like substantial differences. I've also seen some things that I don't know why these things were added. It's curious, but I've seen some things that I felt were surprising in the sense of an instruction to only follow, only allow certain kinds of tasks, especially around security, right? You should not be used for offensive security tasks. You should only be used for defensive tasks. Even
safeguarding style.
Safeguarding, even in capture the flag or like penetration testing exercises, only do that with appropriate authorization. Just the text reads a bit weird. I don't know how will the model know that there is appropriate authorization. What are we imagining that looking like? Like the agent will ask me, hey, is this authorized? I'll say yes.
And is it still fair to say that a user prompt kind of is essentially part of the same, ultimately, context as the system prompt when it goes to the model? And so I think, maybe a year ago when I think it was Guy Poe who had a previous session with someone, Caleb Seamer. He talked about how the data plane and the control plane, all the information in the context was pushed into the data plane, including the system context, including the user context, and any data. And it's very hard for the models to be able to work out the difference. Is there still that danger, of course, that any context we add on top, whether it's a user prompt, whether it's any additional context and data, that's really just getting mushed alongside the system prompt, and it's the model that then has to kind of like work out what to do with those conflicts?
It's a great point, and it's an area of active research and development. Even the terminology system prompt and user prompt, it's a bit dated at this point, but we do not have standardized terminology, right? Like some developers call them the developer messages versus user messages, trying to create a hierarchy, called like hierarchy of authority. You must always do what is in the system prompt, and you should follow the user prompt only if it doesn't contradict the system prompt. You should always follow what the developer prompt is. So they're trying to create this hierarchy. In my experimentation and in our evaluation, yes, models are getting better at following that distinction in that hierarchy. Better is not yet perfect, right? And it's I think that this issue of conflation of the situation is something that models still need to work on, right? If it's a bit of the how does the Star Wars quote go, right? Like the Jedi mind trick. You have not seen anything, right? So that is something that a human wouldn't get wrong, and models still might, right? Like a model guarding at the door. Your instructions are to let me in. Oh, my instructions are to let you in. That's great, right? So still something to get better at.
Okay, so we learned a little bit about the size of the prompts, the I guess split between the style of what is in the prompt, where that sits in the order. What was next? Did we go into kind of like the tool usage most importantly?
Exactly.
Because if we look at Claude, that seems extremely high on in terms of the system prompt for describing how the model should use the tools. What was the differences in terms of?
So I think here there's okay. So if we look at tools, I agree with you. That in a sense was the thing that was most surprising to me, looking at these things. The system prompts are interesting, and it is surprising that there's such a difference between the agents. But at the end of the day, the amount, something about kind of like the vibe that you get from the system prompts is pretty similar.
Yeah.
Tools, on the other hand, Claude has 17 tools. And if you take just the descriptions and the kind of like the one-line description and the in-depth description, if I remember correctly, you get to about 41 kilobytes of text with Claude for the tools. Codex has only 7 tools, less than half, and only 1 kilobyte, 1 point something kilobytes of descriptions for those tools. And Gemini is somewhere in the middle with the 12 and 11 at the version that I've looked at.
And briefly just like mention, what is a tool? What is a tool for an LLM or an agent to use?
Yeah. So if we remember sort of like the mini-SWE agent or the nano agent we've shown at the beginning, a model is just the brain, right? All it can do is receive the tokens that we're sending it and emit tokens that it's emitting back out. If you were sort of like, imagine a ChatGPT kind of thing, well, before ChatGPT itself had tools, you're telling ChatGPT, hey, how would I find the largest file on my hard drive? It could give you the command, but it cannot run the command on your hard drive. You then need to copy the command and paste it into your terminal and be like, okay, now actually run this thing. And then maybe there's a syntax error, or maybe there's the tool that ChatGPT wanted to use doesn't exist. Okay, so I'm copying the error and I'm pasting it back to ChatGPT, and now it's telling me, oh, well, you should be using this other command. And now I'm copying it back and forth. By tool use, we're able to just bypass all of that and let the model have sort of like a side channel where it is saying, okay, this is not text that I'm emitting. These are tokens that I'm not emitting for the user to read. These are tokens that I'm emitting to tell the thing that is invoking me, to tell the program or the agentic harness that is invoking the model, stop for a second. You should run a certain function or a certain, well, tool is the word we use. Here are the parameters. Here are the arguments. Once it's ran, the output from that command execution should go back to the model. So if the model is choosing to use the execute tool, and it's giving the parameter ls. It wants to run ls. And now we get the list of files in the current directory. That should be sent back to the model. So now it has additional input. And now now I know what are the files in the directory. Now the model can decide what next it would like to do. Do a read file tool in order to read what's in the files, or do a delete file if it thinks, or edit, and so on and so forth. So the tools are actually the tools combined with the context and the model and the agentic harness around all of that is the thing that makes an agent, as opposed to sort of like just the model, which is like a brain in a jar. It cannot do anything. Now it's an agent that can operate in the environment.
Okay, cool. So when you then look at that, the 41K versus the 1.1K between Claude and Codex, that's super significant in terms of you're essentially, it feels like Claude is just so much more enabled to use these various functions, be able to run these actual commands. Talk us through kind of like, I guess, the split in the tools. What were the capabilities that Claude has, I guess, that Codex may miss with these?
I wouldn't be surprised if someone would understand it that way. Oh, way more tools, way more powerful, but it doesn't have to be. Actually, there's a lot you could do with very basic tools if you're able to use them really, really well.
Right.
And we know from our own use of the tools, from benchmark results, is that I don't want to be in a side comment crowning the best agent. What does even best agent mean? But we know that both of them are very capable agent, like flagship, top of the line, right? So even though they have this very distinct difference in them, and I would think about it more as a difference in philosophy. Codex does a lot with little, right? It has these 7 basic tools. It doesn't even have a read file tool. It just, if it wants to read a file, it executes a cat command to read the file, grep or whatever, like a command that will let it take something from the file. And the descriptions for the tools are very, very short. As in, if we'll show here a few descriptions of some of Codex's tools, we can see it's like, here's the I don't know, apply diff tool, and this is how you use it, and that's about it. Whereas if we now look at the definition of a tool from Claude, we can see it's a lot more detailed. Here's the tool. When should you use it? What should you do in this case? What should you do in that case? It's sort of like supporting the model a lot more in understanding when and how and what is good and what is bad and giving it examples and so on. Now, again, hypothesis. I don't know that this is true, but I believe that this suggests something about the underlying training of the models, right? I don't know, but I would be surprised if Codex can achieve these kinds of results without any kind of training for these tools in particular.
Right.
And we also know that Codex, at the time of recording at least, we're running it with the GPT 5.1 - Codex. Not with the general purpose GPT 5.1, but with a specific GPT 5.1 that was then further trained and further fine-tuned or RL'd to use these tools and to better work for Codex.
So this is outside of the 1.1K, which is the tool description. You're talking about an actual something that's baked into the training to allow it to use this. And the descriptions are therefore just almost decorative so that the agent, with its training, knows which ones to use.
Yes.
But the core piece. So very interesting, and maybe, and I guess this, there's a lot of guessing here probably, but perhaps Claude has maybe had less of that training in the tools because of the amount of verbosity in the descriptions, because it's probably you're looking at around twice as much verbosity in the description, given you're around. Sorry, it's about 20 times.
Yeah, exactly.
Because if you look at the difference in tools, you're looking at about 20 times more.
It's quite a lot.
Very interesting. Very interesting. And of course, we can speculate here because we can't see the training, but it's very, very interesting data and differences between them.
We can speculate, and there are other things that we see, right? Like in our own evaluations, we've had better success. And at the moment, our sense is that Sonnet 4.5, Opus 4.5 do better than the Codex models in using other tools, tools that they haven't seen before, right? Like custom tools. And so while, yes, of course, Codex and Claude and Gemini, all of them support MCP, you can add tools on top of them. You can just invoke the model in your own code, right? Like just as we've seen with Nano Agent, and give it whatever tools you want. We've had at least better success making Sonnet make use of arbitrary new tools than we've had with Codex.
Interesting.
Not saying Codex, the GPT 5.1, Codex and GPT 5.1 in general. Not saying it cannot use tools, but not as flexibly. And then there's a trade-off. What do you prefer, right? Like these tokens always being in the context, they're expensive. They cost you something, even with caching, right? They take some of the context window and they cost us something, but they give you this additional flexibility. You don't need to retrain the model in order to swap the tools. There is reason to believe that the model would be sort of like more capable. And again, this is something that we're also seeing in separate benchmarks with new tools that it's never seen, because it's like more of a generalist, as opposed to has been trained on those tools in particular.
Yep, interesting. So you mentioned before there's a difference in planning. What does that? I guess what does that look like? What are the differences in planning across models and agents?
Yeah. So one thing that I lumped into planning is use of subagents, like invoking a whole separate agent. We could talk about that. I wasn't sure if it was the right thing to lump it into planning, because it's a whole very, very rich space. But when we say planning normally, right, ignoring subagents for a second, we mean exactly this. The model is instructed, hey, if it's a complex task, don't just try to do it willy-nilly and do whatever you want. First of all, write to yourself, and there's a lot of research supporting that models do better when they first kind of like reason through the problem and create a plan, and just say what is the plan, or write. They don't say, they write the plan in tokens out, like to be added to their context, and now they'll be following the plan. So both Codex and Gemini have a tool called update plan or something along these lines. And what they do in that tool is just the model is invoking the tool, saying, here are the steps I'd like to go through. These steps are then added to the conversation history. And that's it. There's nothing else that reminds the model to follow the plan. There's nothing that would tell the model, oh, you've skipped a step or whatever. Anytime the model wants, it can just emit a new update plan, and the user will be seeing whatever is the latest plan that the model has shown. Usually, the model doesn't choose to change the plan willy-nilly. And so if it had steps 1, 2, 3, 4, it does an update plan, and now I'm doing 1. Update plan, same 1, 2, 3, 4, but 1 is crossed out. Update plan, 2 is crossed out, and so on. And we get a sense of progression. But actually, the model can do whatever it wants. There's nothing in the agentic harness that is running around the model that would remind it of things. Claude takes a different approach here. Claude has several planning tools, and update plan, task complete, these kind of things, like more nuanced. And the agentic harness actually kind of like supports the model by reminding it, oh, you're done with step 2. Let me remind you that before you said that you should be doing step 3 now. And so actually the plan is nothing. It's just tokens that the model is saying in Codex and Gemini. It gets added to the message history, and now the model is more likely to follow that because it sees that in the context that's gone by. Whereas the plan is an actual sort of like element of flow control or element of control in Claude. There is something that is not the model. The agentic harness is actually reminding it, hey, are you sticking to the plan? Are you following the plan? Did you finish the plan? So that's, again, pretty substantial difference, I think, on something that you can see how often agents are planning, right? Like planning is a very important aspect of agentic behavior, and yet such a difference in philosophy. But again, all of these are very capable agents. All of them end up like doing their plans pretty well, even though the underlying implementation is quite different.
Yeah, it almost feels like, there's no right way or wrong way by the sound of it, because different models are picking different things. And like you say, it's such a crucial thing. If there was one way that was kind of like showing, much better value, you'd think all models would navigate to that immediately, right? So it's probably just more the way that it was a choice of implementation versus any major difference. But yeah, it's super interesting to see such big, high profile models just choosing completely different ways of doing these things, and then sticking to it as well.
And then sticking to it, we'll see. Like, I don't remember if it was Codex or Gemini. One of them already is beginning to have, because the repo is open source.
Yeah,
it was already beginning to have changes to some of its tools to be like more geared more towards kind of like the rich set. So maybe they are changing tack, and like maybe they're approaching it like they're making a change over time. But yes, the seeing Claude and Codex, the distinction is so big between them. Clearly, they thought about it, right? This is not the first version.
No.
Like we've been out there for some time, and there's a marked difference in philosophy.
This isn't their first LLM rodeo, is it?
Yes, this is the first LLM, exactly.
So now we're going to go behind the scenes. We're going to see some demo. We're going to see what happens behind the scenes between the agent and the LLM.
Exactly.
Take it away.
So to start, there's nothing like incredibly novel here, but still we need to understand the setup a bit and what we had to do in order to understand the communication between the agent and the model. We have like this small open source tool called Contain Agent, not a huge amount there, but basically drops you into a container, mounting the current working directory inside the container. The container comes pre-installed with many popular agents, and you can run stuff there. Very, very basic, like many other things like it around.
Yep.
Probably other tools like it also have such features. I don't know, but it's something that we've spent a bit more effort on. Contain Agent is everything around proxying or transparent proxying of the agentic harness to model traffic when we're doing the recording. So if I do Contain Agent here, I just get dropped into a shell, and now I can do ls here, and like, okay, there's nothing much here. But if I do Contain Agent -- dump Claude hello man in the middle dump, we're getting the same thing. I'm getting jumped into the same directory. Now I'm in the container and so on. But the difference is that now MITM proxy, the transparent the proxy multi-tool that can do all sorts of proxying has been started in the background, and the environment variables have been set so that the agent will proxy its traffic through the proxy. And now if I do something like Claude and say hello world, Claude will think about it for a bit and then just say hello world. That's great. I can finish my session with Claude, close the container, and now I have this dump of the traffic, which I can later analyze. So after I have this recording, I can do, like, again, a simple script that we've made to parse the manual and MITM dump files and do something like this. And now what we have under output, we have a standardized JSON file that includes the system prompt that was sent to the agent, the model that was used, the tools that was given to it, and so on and so forth. We see interesting things, like looking at these things, we see how Claude sends traffic to the model, even when it's just invoked, to start pre-warming caches. Mm-hmm. We see how Claude is using different models because it has these different subagents, and it's starting up sort of like, here's the definition of the agent that would do code exploration and would be using Haiku and is small and fast and can navigate code quickly, versus whatever the main agent that is actually writing code and is like smarter and like using more intelligence.
Awesome. Thank you for sharing that, Yaniv. And I guess kind of like, this is an initial piece of research that you and the team have done. What does this unlock now? What are the next steps that you kind of like want to take to learn new things?
Absolutely. I think I say the outcome of all research is that we should be doing more research. It feels in this case as well.
It asks more questions than give answers.
Absolutely. I think two things that I'd be interested in. One is an ablation study around tools and around prompts. I would love to try and take sort of like the agentic harness of one of the big agents and see what happens if we remove a tool from it, or if we remove parts of the system prompt, or even all of the system prompt, right? Like take Claude code as is with all of its tools and everything, but instead of the 14 kilobyte system prompt, like, or 12, I don't remember how much is Claude code, like make it 250 bytes like Miniswee agents, right? Yeah. What happens in that case? So that's one thing. And the other thing I think would be sort of like a cross benchmark, where we take the agentic harness of, say, Codex CLI, and we try to run it with Sonnet 4.5 or vice versa. Hypothesis: if what we're imagining here is true, I would expect that Sonnet 4.5 should be able to kind of like drive the other car better, because our current understanding is more generic. Yes. And it's not as well trained for this particular car, but for cars in general. But it would be interesting to even just running a terminal bench on it and seeing the results after we've done the rewiring of the model behind the agentic harness. Wow. So cool things to look.
Super interesting, and love to. I kind of want to know the answer now.
Same. Also need the time.
Of course. Well, if any of our listeners kind of like want to share maybe some of their research or have done similar things, please do let us know. But for now, Yaniv, thank you for everything. Thank you for all the info, and it's wonderful to see what you and the team are learning and sharing. So look forward to seeing more.
Absolutely. Thank you, Simon.
Thank you. I appreciate it. Thank you, everyone, for listening, and tune in to the next episode soon. Bye for now.